Okay guys, this thing is amazing, but it's gonna cost you. Let's take a step back. You're doing astrophotography. You're using a telescope that you have like a large sensor. Let's say you have a full frame sensor, like this camera here. It's attached to your telescope, but there is some tilt somewhere in the system. So the corner stars in your full frame sensor, maybe even on your APS-C size sensor, those corner stars, they're elongated, they're not perfect, and the other corners are fine, and it's super annoying. You know that you're supposed to use the tilt plate adjustment there to fix all of that manually. Look at the stars, do a small adjustment, reconnect everything, look at the stars again. And some people, like in all fairness, like Player One cameras, make it easier by allowing access to the screws from the back of the camera, so you don't need to detach it, for instance, after each adjustment. But this is insanely expensive in terms of effort, and it's extremely frustrating. And to tell you the truth, I never, ever do it. It's just too much freaking work. So I've never done tilt adjustment. Like, I tried, I always fail. The tilt adjustment problem, this thing here, basically aims to completely solve it and make it easy, even for people like me who are lazy, to have perfect tilt with your telescope, so that you use that expensive telescope you bought. Let's say you bought the SQA 106. That thing is like, what, $4,000, $5,000 US. But you're not using it to its full potential if you don't have the tilt properly adjusted. This will do it for you automatically, or manually if you wish. But it has basically tiny motors here, there, and there, and they will move this thing up and down using some software to adjust your tilt. It can do it, you can tell it exactly, like, yeah, move 0.1 millimeter in this direction or that direction on this particular point, right? You can tell it that directly, or you can also rely on some software, free software, to basically analyze all of your star field, determine how your sensor is tilted, tell the Wanderer Astro ETA. So ETA stands for Electronic Tilt Adjuster. So tell the Wanderer Astro ETA, and then the ETA will say, oh, okay, I need to do this, and will automatically adjust all of those distances, and magic, your tilt is fixed. This is the problem that this thing here promises to solve. So this is, as I was mentioning, the Wanderer Astro ETA for Electronic Tilt Adjuster. That thing, I've tested it. It works. It's amazing. Spoiler alert. But you will go into the details. The one thing it's not is cheap. It is not cheap. This thing. Okay, take a moment to think about it. It's just like basically 3 steppers and some awesome little machining, like custom stuff, Wanderer Astro, with some awesome software, and probably quite a lot of R&D that went behind it. How much should this cost? And yeah, have a number in mind, and then I'll tell you the real price. The real price for this thing is $850 and $849 US. It's available at that price on shops in the United States, like at Gina, and I have all of the links down in the description if you're interested. But this is indeed not cheap. So is it going to be worth the $850 US? We'll go back to it later in the video. For now, suffice it to say that you're getting this, but also in the box, you're getting some other things. You're getting some stray light blockers, if needed. I didn't need them for me. You're getting a USB cable, to connect stuff. You're getting an M48 to M54 adapter, which can be good to connect this ETA, which is M54. The opening here is M54. If you're using it with an M48 telescope, you have the adapter. And it comes with tons of screws to attach your equipment to it, because I'll show you in a moment, but it's designed so that you can use this thing with an off-axis guider that actually fits in this groove here. The off-axis guider fits here, and then the stock is in this direction, and then a filter wheel, and then your camera with the tilt adjustment place removed, all screwed in via screws that will be like in those 6 slots here, and then you attach that to the telescope, and you have exactly 55 millimeters of back focus, even when you include the Wanderer Astro ETA. It's pretty well thought out. If you have compatible off-axis guider and camera, there's a lot of information in the manual of the ETA, so before buying it, if you're planning on buying it, read the manual, check compatibility, and understand how it works, right, to really make your decision. So with that, first I'll show you how I attached my camera to it, so this camera to it, and it's, yeah, you'll see that's not the standard way, like I don't have a compatible OAG, etc. And then attached it, which telescope I attached it to, and how this gets controlled with the software, etc., and the actual tilt results. So let's get to it. Okay, so here is my setup with the camera. It's a full-frame SkyEye 24 AC camera from Toptech, attached to the Wanderer ETA. Now this setup is not the classical setup you would get with the Wanderer ETA. Normally, first you'd have a camera that you can remove the tilt adapter from, or some piece of the camera, and you gain 5mm of back focus doing that, and then you can screw it in. It's very important that on this side it's screwed into the Wanderer Astro ETA using those 6 screws here on the edges of the aperture, of the M54 aperture. But for me, I have an old version of the SkyEye 24 AC, so I'm not able to do that. So I cannot save 5mm of back focus. And it actually means that with the camera plus the ETA, and if I were using an off-axis guider and a filter wheel, I'd be at 60mm of back focus rather than 55mm, which for me is fine because I'm planning on using it with this SQ-55, which, as long as we reach focus, doesn't really care about back focus. And this is also unusual because you can see the space here, and it's very well detailed in the manual. I'll put the link, of course, to the product page down in the description, as well as the page where you can buy the Wanderer Astro. And there's this groove there that you can see the camera has like sunk into here, and you see this opening here is meant for your off-axis guider like stock, the one that goes towards the camera. And so normally you would have the off-axis guider at this place, screwed in using those 6 screws directly into the ETA. Then you'd have something like your filter wheel, and the attachment method depends on your off-axis guider and would be screwed into the off-axis guider. And then you have your camera, and everything is screwed together and there's no issues. And then, because at the camera level you've removed the tilt adapter plate, you gain back those 5mm, and with the camera, with the filter wheel, and with the off-axis guider, everything like on this side of the ETA, and then you can just screw in the ETA to the back end of the telescope using the M54 threads. So this is not a typical kind of installation, but it is possible that way. And the reason for that is that I simply don't have a compatible off-axis guider and filter wheel. I do have a Toptech off-axis guider that is compatible, but the opening is not M54, it's actually M48, and I didn't want to vignette the sensor because it would kind of defeat the purpose of this experiment. And so I ended up not using it. I have the camera directly connected to the off-axis guider. And when you do connect it, by the way, and again, it is very clear in the manual and also YouTube videos by Wanderer Astro, it's important to understand like the orientation that you have of the camera relative to the ETA. So you can see that if the camera is like I have here, the camera sensor, it's at 90 degrees to the ETA. If I had the long edge of the sensor like this, like the rectangle with the long edge towards the top of the ETA, it would be 0 degrees. And that's going to be somewhat important in the software itself for Wanderer Astro. Actually, according to their manual, you need to know that angle and to be less than 10 degrees off. So here I know that I'm at 90 degrees, so it's not going to be a problem. And then for me, because I'm connecting it to the SQ-55, I didn't really hesitate. I have the Wanderer Astro. Normally you'd have filter wheel, off-axis guider on this side of the ETA and then connect the ETA to the telescope. But for me, I have just the camera. Then I use my usual 55mm of spacers from ZW actually. Add them to my setup. So here, from here to the camera sensor, we actually have 60mm of back focus. But again, SQ-55, it's not going to be an issue. And then I can add this to the image train here at the back. So here we are, everything is beautiful and connected. I have the Wanderer Astro ETA here, I have my camera, I have the telescope, I have the EAF, I have my guide scope and guide camera at the top because again, for my particular, like with my equipment, I wasn't able to make use of my OAG directly. Again, everything is in the manual. Check whether your own equipment would be compatible. And then I'm using the Skywatcher 150i mount to control all of that. And if we look at it from the other side here, I have the control center for everything. It is the Gaius S2, so this is a Windows-based computer because obviously the ETA here will not work with something like the ZWASI Air. It actually depends on some software and some plugin that is for Nina. So you do need a Windows PC, and there's Wanderer Astro software on there that you could use just on its own and control everything. But you, ideally, if we want to do the tilt adjustment automatically, like so that everything is done for you, you need this Windows PC, Wanderer Astro Nina, and then a plugin called the Hocus Focus plugin. So let me show you how it looks in terms of software. So I'm going to remove, this is unrelated. So we are looking here at Wanderer Empire 2.2.7, which is the overall Wanderer Astro control type of software. And here we have the ETA, the electronic tilt adjuster, connected. And here we are able to do things manually, right? I can switch, like change the distance that we have on each of the points that we could adjust. Like this point here is point number 1. You can see it as I hover the mouse over here, it gets highlighted in white. So here it is, point number 1, point number 2, point number 3. So I could just, manually look at my star shapes in whatever software I use and then adjust the distances here as I wish, either by adding or removing from those distances, or by changing a number here and then setting this to go to, right? And so you can change your tilt like manually, but electronically at the same time, if you see what I mean. Like, select your tilt adjustments and tell the ETA to apply them. There's no fussing around with screws as you're trying to take images of the skies, as you're trying to do the tilt adjustment, which is always horrible. Yeah, this is really nice to have. And also one of the bonuses that you have with the ETA is the ability to change the back focus a little bit. For this guy here, the SQ55 doesn't really matter, but for other telescopes where 55 millimeters of back focus is very important, it can matter. And instead of having to adjust the back focus by removing the whole imaging train at the back and then adding a spacer and putting it back in or doing some weird adjustments here and there, you can just say like, yeah, let's just add like 0.1 millimeter of back focus, see what happens. Although, as I understand it, the ETA has up to 1.3 millimeters of travel, so you're not going to be able to adjust the back focus like that much, but it is adjustable there. And you can save your presets, right? So if you are using this whole imaging train at the back on multiple telescopes, save your presets and then reload them as you move from telescope to telescope. That's also pretty cool. I think it's overall very well thought out. And you have also a diagram here of the exact like kind of 3D tilt that you are anti-tilt maybe that you're applying with the ETA on your imaging train. Pretty cool stuff. But the really amazing stuff happens here under the automatic tilt adjustment here. And this makes use in Nina of, if you go to plugins, the one that we are interested in is the Hocus Focus plugin. You definitely need to have that installed, and you want to make sure that you have set the safe path to some path that Wanderer will be able to look at. And that's what I did here. And when you actually access the imaging tab in Nina, and what you'll be looking at is this aberration inspector tab, and you'll be using this run autofocus setting here all the time. And that's what I did. And you just effectively follow the instructions from Wanderer Astro, and Wanderer Astro will read the results from the Nina Hocus Focus plugin and just decides exactly what changes need to be made. It's actually pretty amazing. And later in the video, I'll show you the results, how it looks when I look at the before and after, because of course, I made sure to have some tilt on my camera. The camera itself has a tilt adjustment plate. I used it to introduce like 0.8 millimeters or so of tilt. I'm not sure, it's like just eyeball it, but quite a bit of tilt. And so I took a picture with the camera-induced tilt intentionally, right? And a picture after I ran the automated Wanderer Astro kind of tilt adjustment. And it's, yeah, I mean, this is the SQ55. I'm pretty sure this OTA like breaks the laws of physics or something. Even with a huge amount of tilt, it doesn't really seem to affect your images that much. It's a bit frustrating, to be honest. So it's not the best scope for the demonstration, but it is the one scope that I have that I can use for this demonstration for the time being, because I don't really have any other telescope for the ETA right now. I wish I still had like the SQA 106, but I already sent it back to ASCAR. So yeah, we're stuck with this little miracle of a scope here to do this demonstration. But yeah, I have we'll be able to compare both of those pictures. And just to show you a bit, like, you have a full tutorial on YouTube, so I highly recommend checking that. But just to show you the steps, I'm going to reset the parameters. And you can see it will ask you, like, okay, where does Hocus Focus save the files? So I put the path that I have also in Nina under plugins set here, right? So that's simple enough. And then in the next step, it will ask you, like, okay, how many microns per focuser step? And for me, it's almost 1 micron, so it wasn't a big issue, but it's not a given, right? This will depend on your focuser, on your telescope, so you don't know by default, right? But you can ask the ETA to measure that. So what it will do, it will ask you to run an autofocus session via the aberration inspector from Hocus Focus. Then it will move the ETA back focus will move its own back focus to some other point using a known distance. It will ask you to run this again, and then it will read the results and determine, like, oh, you went from this autofocus step to that autofocus step. Therefore, you have X microns per autofocus step or autofocuser step. So, some basic stuff, but still pretty smart. And then it also determines whether it's reversed or not in terms of direction based on that. And then the next thing was the camera angle. So you need to set your own sensor angle. And there, for me, I already showed you, it's 90 degrees. They do provide some very handy examples directly in the app. I'm a software product manager. I look at that and I like that. I like that as an end user, I can, access that immediately, directly from within the software. It's super well built. Well done to whoever built this piece of software and designed it in the first place. But anyway, there's another thing, whether, it's 90 degrees, but is it like 90 degrees or is it like 270 degrees? Right? So is it upside down or not, basically? And again, if you click measure, it will ask you, like, hey, make sure you take 1 autofocus run, or maybe 2 even, I don't remember exactly, but it will measure that and it will check or not the checkbox here based on the results. Then you set up your camera sensor size. For me, it's full frame and those dimensions are correct. And then you're good. Then you can go into the automatic tilt adjustment. And really for that, it's as easy as, again, taking a run autofocus there. After it's done, go back to Wanderer Astro software and click on automatic tilt adjustment. It will read the results and it will automatically move those 3 adjustment points by the right amount to get you back to a flat or flatter field. It's really impressive to see, although, to be honest, for me, I had to do it in 2 steps. Like, the first adjustment was not quite enough, so I had to do another run of autofocus using the aberration inspector and then automatic tilt adjustment. But overall, you can see this is some pretty impressive stuff. Although, well, to be fair, the price is also pretty impressive. I want to go back inside and show you the actual before and after images, as well as some screenshots of how the tilt appeared as measured by Hocus Focus, the aberration inspector, before and after adjustment. So let's go inside and check this out. Before we do that, let me know what you think of this ETA, the Wanderer Astro, down in the comments. I'll be fascinated to read your comments. While you're there, like the video, it really helps the channel out. And if you want to help the channel out even more and you're planning on buying anything like the ETA from Agena, High Point Scientific, First Light Optics, even Amazon, if you do so after clicking one of the links I have down in the description, it will help me out at no cost to you. And if you want to become a direct sponsor of this channel, make all of those videos directly possible, you can become a channel member. It's the join button next to the subscribe button, or you can become a Patreon supporter. The link is down in the description. I have a Discord channel for my Patreon supporters, kind of like in a beta test, and some of my ranks can access my videos early and without ads. You guys, you know that you're making all of this possible. Thank you so much for your support. With that, let's get inside and look at the results of the Wanderer Astro ETA. Okay, and I'm ready to show you the results, which, as I was saying, are pretty impressive. Let me start by showing you the result of the autofocus, the first autofocus run in the aberration inspector that told me that, I had pretty bad tilt. I honestly don't really know how to read all of that, except that, there are a lot of adjustment steps that were necessary to achieve whatever, a flat field would look like. But we had this as an output from the Hocus Focus plugin in Nina. And in the Wanderer Empire software, as you click on automatic tilt adjustment, it reads the results from the Hocus Focus plugin, and it tells you, okay, this is what I'm going to do with the new position being this, that, and that, right? And bam, it does the changes as soon as you click on OK, and it just works. And as I mentioned earlier, I had to do 2 runs to really get a good result. And this is what my good result in the end looked like in Hocus Focus, with everything pretty much well aligned. Not quite perfect, especially this top left should be adjusted a tiny bit more, right? By 9 something microns, okay. But we're very close to proper tilt. And I could have done another run to really dial that in, but as we say in French, le mieux est l'ennemi du bien, better is worse than good. So I thought that was good enough, but it shows you that you can do by further increments if needed. And overall, this is what we got before the adjustment on the left and after the adjustment on the right on this full frame camera. So we can look at the corners of the image, because that's where you'll see the most issues. Let's say something like that, top left corner. And we're going to look at the top left corner in both images before and after. And to me, it does look like before we have the stars are slightly elongated in the diagonal direction, very slightly, especially if you look at the larger stars there. They're slightly elongated before, but then after, they're pretty much perfect, right? So we're seeing a bit of a change already. It's pretty nice. It means that the Wanderer Astro ETA did something. That's good, especially for the price. And then if I go to the top right corner, we see a similar story. On the left is before the adjustment, and this time it's elongated in this direction here. Whereas if I look at the after adjustment, I get perfect stars, basically. So imperfect stars, even though they're still pretty good. That's the beauty of the SQF55 versus perfect stars on the right. This is really good to see that we are seeing an impact. But really, the biggest impact will be on the bottom right edge of the image. You can see this is the part of the image that is most affected by tilt. The stars are clearly out of focus. We can even see them opening up to some area with lower flux in the star, and we are here really affected by the tilt that I artificially introduced in the camera. How does this look on the fixed version? Well, there's no comparison, right? It looks pretty much perfect on the right after the adjustment compared to on the left before the adjustment. I mean, yeah, come on, that's a huge difference there. And yeah, that is what there is to know about the Wanderer Astro. Let's look at the top left for the heck of it, just to complete our analysis. Again, in the top left, on the left-hand side, let me put the same top left for both. On the left-hand side, we have some elongated stars, kind of in this direction. They're getting diamond-shaped, not perfect. And then on the right, the stars are perfect. The tilt has been fixed. Everything is good. And something that in my long career as an astrophotographer, I've never really managed to do manually, is done automatically by the combination of free software with Nina and Hocus Focus, plus the Wanderer Astro tool and the Wanderer Astro software. I mean, this is honestly amazing. And this is on an ETA that is actually pretty good at ignoring tilt effects. So imagine on a really fast like Takahashi FSQ 106 with the reducer, or on an epsilon type of series, or HNT kind of telescope, hyperbolic Newtonian super fast optics. Or even I think it could be useful for APS-C size sensor on something like a Quattro 150p Newtonian, cheap Newtonian, but f3.5. So overall, pretty sensitive to tilt. And then suddenly you have this tool that lets you remove that tilt. So we can see it is effective, and it can remove a huge source of frustration with when it comes to astrophotography, because tilt, as I said earlier, I never managed to really do it, and it's something that I skip because it's just too frustrating. So this thing here, this Wanderer Astro ETA, is it worth the $850 that Wanderer Astro wants for this? Well, the answer is it depends, really. If you are very into your star shapes and you've bought an expensive telescope to use with a large sensor, or even a smaller sensor with small pixels, because small pixels are more sensitive, will show you optical aberrations more than large pixels. But if you have like this kind of scenario and you want to get the most out of your expensive telescope, spend the dough. Get this $850. It will help you out get the best results out of your telescope with very little pain. And that's especially true if you're going to be moving your imaging train from one telescope to another, for instance, and then you can have different profiles with the different corrections that are needed, or just redo the tilt adjustment. It takes like 20 minutes before you start imaging on your new telescope. If you have an expensive telescope and you already use like Nina and Hocus Focus, and you know how to translate, the results of Hocus Focus into how do I turn, like which screw do I turn in what direction on my camera, you do the adjustment and it works out. You don't need this. This is not for you. But if you're like me, lazy, and really like I just cannot do tilt adjustments myself, then this is for you. And honestly, for me, I probably will ask Wanderer Astro if I can buy it off of them, because it can be very useful for me when I do like telescope reviews. Although I would need to buy an off-axis guider or an adapter for it. Yeah, okay, some things to consider. Not sure if I will, but it could be very useful for someone like me who uses a lot of telescopes to do testing on them, or for if you are having issues with tilt. You have money burning a hole in your pocket. You want to make the best out of the telescope that you bought and the equipment that you have. We already spent so much money. So what's $850 more? It's a lot. And it's the same price as the entire SQF55 telescope. So it's really up to you. You saw what this can do. It can do the tilt adjustment automatically, get you to perfect stars across your field of view, at least as much as the telescope you have can provide for you. So you can get the most efficient way, or the optimal way of using your telescope thanks to that. You can adjust the back focus by up to 1.3 millimeters effectively to really even better dial in things. But is that worth the price for you? Let us know down in the comments. Like the video while you're at it. If you want to support the channel and you're planning on buying anything from Agena, High Point, etc., including the ETA, if you do so after clicking one of the links in the description, it helps me out at no cost to you. And if you want to support the channel directly, there's channel membership, Patreon, link in the description. Thank you so much, guys, for your support. But yeah, let me know your thoughts on this. I'll be super interested. As always, thank you so much for watching. I hope it was interesting. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.